Good morning, good afternoon. Yes, I am at school. You hear the bell. I'm sure you don't miss it very much. We are going to try our first lesson on this remote learning. Hopefully it works for you. Hopefully it works for me. We'll see how it goes. So we are going to be in that salmon colored packet. And we are going to go ahead and get started because there's a lot to do today. So we are on the first page, and it wants to just refresh what we know. There's some definitions up here that I wrote in, some relative extrema, that is a max or a min. And then we have absolute extrema, which is a little bit different. That's what we're going to be talking about today. That is the absolute highest or lowest point on a graph. So we're going to talk about the difference of those two first. So whenever it's asked to identify the coordinates, remember we need an x and a y. So keep that in mind. If it says coordinates, we want to make sure we have an x or a y. So we want the relative extrema. That is where we have a max or a min. We have two relative mins. And that is occurring at -3, 0 and 2, -6. And we have one relative max occurring right here at -1, 3. And what are the coordinates of the absolute extrema? So that means the absolute highest point. So there is no absolute max because we go to positive infinity, both as x approaches negative infinity and positive infinity. So we don't have an absolute max, but we do have an absolute min occurring at 2, -6. All right, so I'm going to give you a second to answer these questions on this side, and then we'll talk about those. So go ahead and write those down. Okay, so again, we have two relative mins, and we have a relative min occurring at -3, -4, and 3, 2, and a relative max at -1, 4. The absolute extrema are at -3, -4 is an absolute min, and 6, 5 is an absolute max. All right, so then they ask us this question: did the absolute extrema occur at the function's relative extrema? Well, sometimes it did, but not every time. This is going to be important later on, so we're going to talk about that in a little bit. Okay, so the next page. Now we are restricting our interval. So instead of looking at the graph in its entirety, we're just going to be looking at a portion of it. So this first one, we're going to look between -2 and +3. And so we want to know what are the absolute extrema in this interval. So my absolute highest point is going to be at -1, 3. And my absolute lowest point is going to be at 2, -6. Now, both of these are also relative maxes and mins. And they're both relative because they are changing from increasing to decreasing or decreasing to increasing within that interval. All right, so now if we change our interval a little bit and we're going between -4 and +1, we want to see how that changes. So now we no longer have an absolute happening at this -1, 3. It's up here at the value -4, 4. I'll write this first. So absolute max is going to be at negative 4, 4, and we have an absolute min at 1, negative 3. In this case, neither of these are relative. Because both are endpoints. Just something to keep in mind when we talk about relative versus absolute. Okay, so I'm going to let you guys do this one on the right, and just take a second to answer those questions. All right, so negative 4 to positive 5. That's our first interval. And we want to know the absolute highest point. Well, we have two highest points happening. So we have absolute max at negative 1, 4 and at 5, 4. This one's relative. This one's not relative because it's an endpoint. And then we have absolute min at negative 3, negative 4. And that one is a relative because it changes from decreasing to increasing. All right, we're changing our interval on the next one. And we are going from negative 2 to positive 6. And we're going to see how that changes. So we have an absolute max at 6, 5. And we have an absolute min at negative 2, 0. And neither, that was a terrible little thing. Neither, oh, I don't know how to make that go away. There we go. Are relative. Okay. So, at what three places could the absolute extrema exist? And so our first answer is at an endpoint. Our second is when we have a relative max or a min, and that is where the derivative equals 0, or where the derivative is undefined. Because remember, on this example on the right, the derivative does not exist at these places right here because it is a corner. It's too sharp to find the tangent line there. Okay, then there's the definition of the extreme value theorem. You're welcome to read that. So we're going to look at this algebraically and graphically. And so remember, increasing and decreasing is determined by the derivative. So that's what we're going to do first. We're going to take the derivative, we're going to set it equal to 0. So that's going to give me negative 3x squared minus 12x minus 9. Set that equal to 0. So I'm going to factor out a 3. So plus 4x plus 3. I am going to factor this. I get x plus 3x plus 1. So we have stuff happening at negative 3 and negative 1. So now I'm going to check my number line, and I'm going to make sure that I state that it is my derivative. And I'm going to check negative 3, negative 1. Feel free to use your calculator. Remember, when we plug in, we're plugging into this step right here to check our signs. And so don't leave your negative 3 out. So if I stick in negative 10, I'm going to get a negative 3 times a negative something times a negative something, which is a negative. And if I stick in negative 2, I'm going to get a negative 3 times a positive times a negative, which is a positive. And if I plug in 0, I'm going to get a negative times a positive, which is a negative. So that is how we can check our signs. So I'm going from decreasing to increasing to decreasing again. So you can see we have a min and a max, and so that's kind of helpful. And we don't want to lose our justification. So f of x is decreasing from negative infinity to negative 3 and from negative 1 to infinity because f prime is less than 0. And f of x is increasing from negative 3 to negative 1 because the derivative is greater than 0. So that's our justification. We don't want to lose that. Okay, the next question says, determine the coordinates, remember we need x and y, of my relative extrema. We know how to do this. So we have a relative min happening at negative 3 something, and we have a relative max happening at negative 1 something. And remember, to find our somethings, we are going to plug our x's into the original. Great time to use the calculator to change your table set independent to ask instead of auto, and then you can just type these values straight in to what's happening. So when I plug in negative 3, I get 2, and when I plug in negative 1, I get 6. And our justification, we have a relative min at this point because the derivative is changing from negative to positive, and then the opposite here because the derivative is changing from positive to negative. So that's our justification right there. Don't forget that. All right, so if we look at this graphically now, now we're going to do the absolute max and the absolute min on this given interval from negative 4 to negative 1. So the highest point, we have 2 of them. So we have absolute max at negative 4, 6 and negative 1, 6. And we have an absolute min at negative 3, 2. This one is relative. These are not relative. You don't have to state that. I just want you to keep that in mind as we do this. So go ahead and change your interval, and I'm going to have you guys do these next two right here. All right, so changing our left boundary, keeping our left boundary the same and changing our right boundary doesn't change our absolute maxes. They're still going to be at negative 4, 6 and negative 1, 6, except now this one at negative 1, 6 becomes relative. The other one's still not. And we have an absolute min at 1, negative 14. Hopefully it's pretty easy for us. Okay, so this is the same problem as the graphing one the other day, or on the previous page. We're not going to do this one right now. We're going to do some examples of that in a minute. So what I would like to do on this next part is state if the extreme value theorem is applicable or not. So remember, in order to be applicable, it must be continuous on the interval. So we want to look for places where it is not continuous. So we want to look for like 0 in the denominator, negative under the radical sign. I don't know if you remember natural log, but natural log cannot be negative. Oh, it can't be 0 or negative. Okay, so this first one, we have x cannot be negative 3. So we are going to say the extreme value theorem is not applicable on the interval my pen does not want to write, sorry. Negative 5, 0, because h of x is undefined at x equals negative 3. So let's look at the next one. This one can be 0, so x minus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to 3. But our interval is from negative 5 to 0. Well, that's not going to work at all. So the EVT is not applicable on the interval negative 5 to 0 because g of x is only continuous from 3 to infinity. All right, and then the last one, we have to know that x plus 7 has to be greater than 0. So x has to be greater than negative 7. Well, that's no problem. So the EVT does apply. On the interval negative 5 to 0 because f of x is continuous from negative 7 to infinity. So all is well. Okay, a couple more examples and we will call the first one done. Sorry I didn't delete this. I tried to record this earlier and it did not work. So I'm doing it for a second time. Get rid of these and then we'll go through these real quick. Okay, so we are going to need a calculator for this and we need to check our endpoints. And so what we're going to do is we need to first figure out where something's happening. So we are going to do that by checking the endpoints and checking where the derivative is equal to 0. So we're going to take the derivative. We're going to set it equal to 0. So 3x squared minus 4x minus 3 equals 0. So you'll notice this is not factorable. So we cannot factor. So this is a great time to use your calculator. We're going to go to y1. We're going to type in 3x squared minus 4x minus 3. And in y2, we're going to type in 0. We're going to do second trace number 5, which is our intersection, and then enter a bunch 3 times. And what that does for us is it's going to tell us that something's happening at negative 0.535. Remember, we want to go 3 decimal places, and 1.869. So those are our 2 values, and I'm going to erase that so I have some more room, but just a little refresher on how to do that if you forgot. So now what we're going to do, change my pen a little, we are going to check our number line, and we're going to put down our endpoints at negative 1 and 3. We're going to put down our negative 0.535 and our 1.869. You can either use your table or you can use your auto and ask, or change your auto to ask and put some values in here to see what's happening. So this is going to be positive, negative, and positive. So we are increasing, decreasing, increasing. And so we need to check our endpoint. So we need to check negative 1. We need to check what's happening when our derivative is equal to 0. And we need to check our other endpoint. Got the wrong number there. Okay, so once we have that, this kind of helps us see what's going on if we have a relative or an absolute. So we have an absolute max happening at negative 0.535 and negative 1.121. And it is also relative, if you want to know. And we have an absolute min happening at 1.869 and negative 8.065. And that is also relative. So we want to check the endpoints, we want to check our other values, and we want to get that occurring. Okay, so this next one, I am sorry. Okay, we have this trig function, and I know that kind of weirds you out sometimes, so I want to go ahead and rewrite this one as sine of x squared plus cosine x. And so when we take the derivative, we need to use a little chain rule. So, little refresher on chain rule, the 2 comes down, we're going to rewrite, we're going to subtract 1 from our exponent, and then we're going to take the derivative of the inside, and the derivative of sine is cosine, plus the derivative of cosine, which is negative sine. So our derivative looks like 2 sine x cosine x minus sine x equals 0. So I'm going to factor this. I'm going to factor out a sine x, and I am left with 2 cosine x minus 1 equals 0. So I want to know, where does sine x equal to 0, and where does cosine x equal 1/2? Because if I move the 1 over and divide by 2, and we want it to be on this interval from pi over 2 to 2 pi. So on the interval from pi over 2 to 2 pi, sine is equal to 0 at pi and at 2 pi, and cosine is equal to 1/2 in quadrant 4. So in quadrant 4, we have 1, 2, square root of 3, that's negative. So this is 60 degrees. Well, that is equivalent to 300. And if we convert this by multiplying by pi over 180, we get 5 pi over 3. So we can check our number line. We're going to put down our endpoints, which is pi over 2, and 2 pi, and 5 pi over 3. We're going to state that it's derivative. So we're going to get this. We're going to check each of our values. So if I plug in pi over 2, I'm going to get 1. If I plug in pi, I get negative 1. If I plug in 5 pi over 3, I'm going to get 5 over 4. And if I plug in 2 pi, I'm going to get 1. So that will tell me that I'm going to have an absolute max at 5 pi over 3 and 5 over 4, and an absolute min at pi negative 1. All right, so just real quick through these last two. This one, we're going to take the derivative. Again, we have chain rule. We're going to bring down our 2/3. We're going to rewrite. We're going to subtract 1, and we're going to get negative 1/3. And we're going to take the derivative of the inside, which is 1. So when I take the derivative, I'm going to get 2 over the cube root of x plus 2 equals 0. So there's no values of x where the derivative is equal to 0, but f of the derivative is undefined at x equals negative 2. So that's going to be our point. We're going to plug in negative 3, 6, negative 2. We're going to see what's happening. We're going to find each of those values. And so we have an absolute max at 6.4, and we have an absolute min at -2, 0. All right, and then the very last one, we want to make sure that this is continuous in the domain. So we know for natural log it has to be greater than 0, so x squared has to be greater than 4. So x has to be either greater than 2 or x has to be less than -2. So since -1, 3 is not fully in the domain of h of x, the EBT does not apply. All right.